Hi, today we're going to be looking at pine flatwoods, and specifically what we're looking at is the role of fire in maintaining this system. Now, fire is used in a lot of different Florida systems, but there's different fire frequencies. Pine flatwoods are useful for the use of fire as a management tool because they have a very specific fire frequency, and it happens a lot more often than in other systems. And so what we're looking at is the fact that in a pine flatwoods area, as a management tool, we're going to see fire used, if the conditions are correct, about every 3 to 5 years. And in this system, you can actually see, based on some burn scars on the trees here, the fairly open look of this habitat, and the fact that the palmettos aren't too high, that fire has been used back here. There's lots of burn scars on the trees. This area has been well maintained with the use of fire. And that idea is that we're mimicking the natural maintenance system of a Florida system, which is the use of fire, which is usually lightning strikes. A lot of the trees around here bear lightning strikes. They have some diagonal burns on the trunks. They show scarring and things along those lines. So this system in particular is the one we look at. And what we want to know is how does fire work? Well, if fire's in the system, obviously the plants in the system are adapted to it. And so this system has a lot of adaptations physiologically and anatomically for the plants that are here. And one of the biggest ones we're going to be looking at today is pine trees and also saw palmetto. And both of these trees are, number one, representative of a pine flatwoods area, okay, and number two, both have very, very well understood mechanisms for coping with fire. So part of what we're going to be looking at in this short video field trip is the idea of how does fire come into all of these systems, and using pine flatwoods as an example of the process. So we're going to talk about fire, we're going to talk about some indications and some techniques in fire, and then we're actually going to kind of talk about a few fire frequencies within the more common Florida systems. So, like I said, today's presentation is on fire in Florida systems. Thank you.
Now in this system, you'll notice that there's been some evidence of a previous burn. It's been in the past because the palmettos have actually grown up higher, but on the tree surfaces of the longleaf pines, you'll actually see burn marks. These are good ways to gather data on this particular area when the last fire actually occurred, because on the trees' trunks themselves, you do see a burn. The burn height is within reason, but the palmettos have grown back pretty high, and so in this case, the fire frequency means it's probably most likely time for this area to burn again, and so we could actually plan a burn. Now in this particular area, we're looking at a mosaic of habitats, and this clip actually is giving you some idea that as we travel along this access trail, we're not just seeing pine flatwoods, we're seeing a diversity of habitats. So we talk about the mosaic, the fact that as you're looking at fire in a system, it's not just one habitat, it's a series of habitats, all of which need some management technique with fire.
Okay, the first thing we're going to talk about today is the longleaf pine, and you see one behind me here. This longleaf pine shows a burn scar on its trunk, and this is the first place we can talk about morphological adaptations to fire. In longleaf pines, as in other pines, they have a very thick, shaggy bark, and this bark is insulating to the inner tissues where the actual living part of the tree is at, and prevents them from being excessively damaged by fire. In this case, fire will travel along the trunk, but will not be able to access those parts of the tree that are actually alive. And in this case, if the fire did get to those parts, it would kill them. So the tree is very well adapted. The other thing you notice is that in this particular area, most pine trees put their needles very high up. And in doing so, they prevent them from being in the usual fire zone, because what we would expect in a well-maintained fire back in this system is that the fire height would not exceed 3 to 5 feet. You do have heat, and heat can evaporate fluids from the tree, but those are usually pretty well dispersed by the upper level wind currents. Okay, so in this case, two adaptations. The first one, of course, is being the thicker bark. The second one is to put the needles up higher, away from the actual fire, where we'd see these frequent low-intensity fires occurring in the system. Second thing is cones. Okay, now when we're looking at these particular cones, the idea we would see with these cones is that they're opened up by heat. They actually have the ability, and this one is actually open right now, to put their seeds down between the bracts, and then when these cones are heated, they drop the seeds. Now, longleaf pines actually do not retain their cones like a sand pine, but these cones will drop, and in those cases, they'll just have the next replacement in there. The other thing is when the seeds drop, they tend to have a small extension on the end, so they actually twirl through the air, and this allows them to be a little bit wind dispersed so they don't fall right next to the parent plant. And like I said, because these things open up during a heat cycle, and this could be drying, because this one was actually on the ground and dried out, and so the bracts opened up. But it could also be opened up by heat, by being held up above the heat high enough so the fire doesn't actually catch them, but so that they actually have some drying and releasing those cones. So, first one, of course, is the actual bark itself. The other idea, of course, is put your reproductive structures higher up in the air. And the other one is put your needles way up above the system. And each one of those is one of the adaptations for these particular pines in this habitat and allows them to survive fire. The second one we're looking at here is saw palmetto, and you'll see a lot of it in the background. Saw palmetto actually protects itself by containing a lot of material within the underground stem for regeneration of new parts. So while the upper structures may burn away, the reserve of food allows for very quick regeneration of these. And at the same time, with the burn, there's a release of nutrients, so there's a flush of new nutrients in the system, and that actually allows these plants to take advantage of that return material and put it back in the system. Because you have to understand, pine flatwoods do not have very nutrient-rich soils. They're very nutrient poor. And so what we're looking at in this case is that flush of nutrients entering to the system allows them to regenerate much quicker. And this is true for all the plants adapted here. It provides clearing. It eliminates some of the competition due to shading. It reestablishes the ability for plants to compete within the system. And those ones that are not adapted, are not used to the fire frequencies here, will not adapt to these particular changes. And so they'll be taken out of the system. And what we end up with is those that are well adapted over a very long period of time, evolutionary terms, to stay in the system. The other thing you'll notice occasionally is that in these systems there's snags, and snags are very useful for a lot of birds and other animals that are cavity nesters and dwellers. But they also can be a little bit dangerous because they can serve as a source of reignition for some of these places. So from a forestry perspective, snags can oftentimes have kind of a double value. The positive side, they provide habitat space for anywhere from insects to mammals to birds. On the other side, though, these large pieces of dead wood can actually act as a reignition source for some of these places. So we have to consider that very carefully. Now, another thing is in some systems that can't be burned, you're going to see some footage of the fact that if you can't burn a system, there are other management tools. And in many cases, birds can occur when they're close to human structures, or when they're in very sensitive areas, or when the fuel load is too high, because that's a very important consideration out here, is that the fuel load may be excessively high in these particular circumstances, and the burns may become too intense and actually kill off the things they're supposed to protect. So, and these cones and other things like that, even though they would be able to release their seeds, would be damaged, the seeds would be damaged, and then we would not have any regeneration for the system. So, fire in these systems is a necessity, but in some cases human intervention has to happen because the natural system has been suppressed, the fire has been suppressed in that particular system.
Now in this case, you actually see the fire front, and it's a very nice fire, very low intensity, creeping through the underlying vegetation. It's not moving up in the trees. It's not going to cause damage to the actual leaves or needles. There will be some drying effect. When we're describing fire, what we're going to be actually looking for is it's going to be how the fire is moving in relationship to the wind. So we have head fires, we have flanking fires, and we have backing fires. Head fires are moving in the same direction as the wind they're being pushed by. Backing fires are moving into it. Flanking fires are actually perpendicular to the process, and so they're coming for the sides. And each one of these has their particular use in controlling fire. So in some cases, you might actually want to start a fire and let it move into the wind, okay, so that in general terms it's not being pushed by the fire. And so we would talk about starting a backing fire because it's moving in opposite direction of the wind itself. But when done right, when you actually finish up with using the fire and its multiple ways of doing it, what you should see is a nice even burn distribution, not too intense. Organic materials have been freed from the vegetation, and when you're all done, what you're going to have is a flush of new vegetation occurring. And in this case, you can see the after fire effects. It's already starting to green up. We still see a lot of the palmettos are doing their usual thing, which is putting out new leaves and shoots from the system there. In this case, you see a few new leaves coming back out from the center. You see the burn scars in the trees are not excessively high, and that overall the entire system has undergone a nice clean burn to help it regenerate. We look at a lot of the fire frequencies and stuff and look at scars on trees. And in this case, the system has done well, but we've also seen regeneration of pines. So it may be that this system is due for another burn to reduce the number of saplings coming out from the system. So what do you do if you can't have a fire? Well, there's a few ways, but most of them end up being mechanical vegetation removal. And as you see in this case, we actually go into a system and actually cause the mechanical removal of vegetation, roller chop or brown tree cutting. So, without fire, what happens in the system? Generally, what we see in most cases where fire has been suppressed, we start to see a change in the actual vegetation. And so in this case, J.B. Starkey, as we move along here, we see the palmettos have become excessively high. One of the first considerations as a fire manager would be the fuel load. Obviously, when you have a lot of this fuel in this area, as you see here, you have a much higher probability of a hotter fire. You also have something called ladder fuels, which is where the fire can actually move up into the canopy because of that. So you need to go back to the idea of moving that fire back to a reasonable level. And that's where we go back in systems that have not been managed with fire for a while, is moving back into the idea of using a mechanical method. And in this case, there was an excessive number of sand pines in the area. The fuel load was very high. It would have been very hard to put a fire into this area because it would have been way too tense. It would have killed off most of the trees in the area that were still allowed to stay, and would have also ruined the seed bank. It would have killed the palmettos. It would have done a massive amount of devastation to this area and would not allow the necessary regeneration to occur. So in this case, the park decided that rather than having a fire, they would use a mechanical method for controlling it. While not the desired alternative, because it doesn't release the nutrients and leaves a lot of dead stuff on the ground, it does promote the fact that it can be a change in the system. It does give the ability to manage the system in much the same way as a fire would, although without the beneficial effects of fire. Remember that these plants are fire adapted, so fire actually helps them with reproduction. It helps with cycling of nutrients. It clears away the competition in the process. And so when we go through these systems and see that they haven't been burned for a while, in some cases we have to settle for a less than optimum thing. Remember that the nutrients need to go back in. You can see a typical pine flatwoods soil here, which is very sandy, lots of shell parts and things, and those nutrients need to be back into the system again so that new vegetation can flush out. And oftentimes when you're done with this vegetation, you see a flush of things like St. John's wort, bitterweed, and a few other things coming up because their frequency, or the frequency of the fire, relies on that. Bunch grasses, wiregrass, like in this case, needs it to regenerate, grows back from the stem. Blazing star, each one of these particular things is adapted to this fire frequency. The two primary things that I focus on is how do the pine trees and how the palmettos handle this, and these are the indicative ones that are there. The other things that happen to bloom up, some of the pineland species that come back after this have relied on this initial idea of burning to free up the system.